intermolecular forces. You have already heard this word in your grade 11, intermolecular forces. What are intermolecular forces? Before I just give you the definition of intermolecular forces, just recall that if you have an ionic compound, ionic compounds have ionic bonds between them, right? Cations and anions, they are attracted by electrostatic forces of attraction, which are known as ionic bonds, right? So whenever we have to change the state of an ionic compound, by changing the state, I mean whenever we have to melt an ionic compound, we have to break these strong ionic bonds between cations and anions, right? And a large network of ionic bonds need to be broken. That's why ionic compounds have high melting points. And when we deal with metals, again, we have to break a large number of metallic bonds, right? So that's why most of the metals have high melting points. But when we see covalent molecules, we have two categories of covalent molecules. On the basis of covalent bonding, we have two structures of covalent molecules. One is simple molecular structures, and the other one is giant moleculars, which are also known as macromolecules, right? Like diamond, graphite, and silica that you must have studied back in your grade 11. Now, usually we know that simple molecules like carbon dioxide, nitrogen gas, chlorine gas, oxygen gas, etc., they have very low melting and boiling points. Samahir, we have just started, don't worry. So how come simple molecular structures have low melting and boiling points? Because whenever we have to change the state of any simple covalent molecule like water, whenever we have to melt ice into water or boil water into steam, we actually do not have to break the covalent bonds because covalent bonds are very strong. In fact, covalent bonds are more stronger than the ionic bonds and the metallic bonds. But then how come simple molecular structures have such low melting and boiling points? Because whenever we have to change the state of a simple covalent molecules, we do not have to break a covalent bond. We just have to overcome the weak intermolecular forces between the molecules. Remember? We just have to break these weak intermolecular forces. And these are so weak that उनके नाम में ही हमने weak लगाया हुआ होता है. Back in grade 11, we also used to call them van der Waals forces. Right? अगर हमें कोवलेंट बॉन्ड ब्रेक करना पड़ जाता ना आइस का, तो आइस का मेल्टिंग पॉइंट भी 0 डिग्री सेल्सियस नहीं होता. That would go beyond 800 or 900 degrees Celsius. Because if we have to melt or change the state of a giant covalent structures like diamond, graphite, or silica, here we have to directly break the covalent bonds. Whenever we have to melt a giant covalent structure like diamond, here we have to break the covalent bonds. And not just one covalent bond, but we have to break a large network of covalent bonds. So if you see this melting point of diamond, that is around 3550 degrees Celsius. Whereas the melting point of sodium chloride is 801 degrees Celsius. For many metals, melting point can go up to 1300 degrees Celsius, right? So it means that covalent bond is actually stronger than the ionic as well as the metallic bond. But simple molecular structures have very, very low melting and boiling point because during the change of state of a simple covalent molecule, we never have to break a covalent bond. We just have to break the intermolecular forces. So intermolecular forces are very important in order to understand the melting point and boiling point of structures, especially the simple covalent molecules. Right? So today we have to start studying about intermolecular forces. So there are there are two types of intermolecular forces that we need to study. अब intermolecular forces में भी different types होती हैं जो आज हमें पढ़नी है. क्लियर है ना यहाँ तक? The first type is known as instantaneous dipole induced dipole forces. This is also known as London dispersion forces. Previously, in syllabus before 2022, we also used to call these forces as temporary dipole induced dipole forces and we also used to call them van der Waals forces. But now actually van der Waals forces is the name given to all types of intermolecular forces. So instead of saying just intermolecular forces, we can also call them van der Waals forces. So as per new syllabus, van der Waals force is the word that would be used for all types of intermolecular forces. It's an alternative word for the intermolecular forces now. And the word temporary dipole induced dipole forces can be found in the previous questions, but it means instantaneous dipole induced dipole forces. Whenever you are going to write this type of force, now you will be using the word instantaneous dipole induced dipole forces. In short form, I would be writing it as IDID. You can also write it as IDID, but whenever you will be writing the questions from paper 2, it is recommended that you write the full name at least once. The difference between the forces in giant and simple structure, in giant structure, giant covalent, there is a large network of covalent bonds. But in a simple covalent molecule, we have a molecule with covalent bonds, of course, but these two molecules do not have a covalent bond between them. These two molecules are attracted with each other, but by intermolecular forces, not directly by the covalent bond. So this is a simple molecular structure. Whereas in a giant structure, all the atoms are interbonded with the covalent bond, directly with the covalent. Got it? Okay. Another type of intermolecular force is permanent dipole forces. It has only one name. And it has a subtype which is known as hydrogen bonding. You can consider hydrogen bonding as a third type of intermolecular force, but basically the hydrogen bonding is actually the subtype of permanent dipole forces. In short, for permanent dipole forces, you can write PDPD. Because it would be easier for us to just call it PDPD than just saying permanent dipole forces. Yes, Ahmad, you have to remember the word London dispersion forces because in our updated syllabus that has been enforced after 2025, they have introduced this word London dispersion forces. So it means you can expect to find this name in the questions. अगर आप खुद से नहीं लिख रहे हो, if you are just writing ID, it's okay, but In MCQs, you can expect this word, Dillon and dispersion forces. Yeah, it's the same thing. आगे बढ़े. So let's just see these forces one by one कि ये किस वजह से आ रही हैं और क्यों आ रही हैं. We'll start from the first type of force, that is instantaneous dipole induced dipole forces, IDI, or London dispersion forces. What is the reason for IDID? Let's consider a simple covalent molecule like chlorine. A chlorine gas has a formula Cl2. If you see a chlorine molecule, we have two chlorine atoms bonded with each other. And these two chlorine atoms, they have zero electronegativity difference between them. Right? So the shared pair of electron must be exactly at the center. Now what happens? Around every atom, we know that the electrons are revolving in their orbitals. Similarly, in a chlorine atom, in this chlorine molecule, let me just draw it separately. This is a chlorine atom and we have electrons revolving around the nucleus of chlorine atom into their energy orbitals. Hassan, beta, that won't be possible to repeat everything again because we started our class around 10:35, so we have studied much. We have written around 3 pages. So try to catch up. Okay, I can show you what we have written so far. First, we discussed about intermolecular forces, जो आप पहले से पढ़ के आए हो. And then these intermolecular forces are basically the forces of attraction between the simple covalent molecules. And we have basically two types of intermolecular forces जिनके हमने नाम डिस्कस किए थे अभी. Now the actual content that we are going to study is, if you see any atom, in this case the chlorine atom, so it has electrons revolving around its nucleus. Right? These electrons can be anywhere, anytime, but they would stay in their orbitals. No, we haven't reasoned for any intermolecular force so far. So it's the first intermolecular force that we are going to reason now. So for a brief moment of time, no, these electrons are revolving on their own. It is not due to the electronegativity difference. Electronegativity difference we're going to study in the second type of force, PDPD. Okay, so the electrons that are revolving around the nucleus, for a brief instant of time, there is always a possibility in any of the atom of any molecule that these electrons may be passing from the right hand side. Let's say if all these electrons get synchronized in a mean that most of the electrons, if let's say, are passing from the right hand side of this chlorine atom. So the right side of this chlorine atom would become relatively more negative as compared to the left hand side. But this would happen for only a very brief instant of time. What do we mean by brief instant of time? Let's say just maybe a nanosecond. These electrons are passing more towards the right hand side of this chlorine atom. So the right hand side of this atom would become relatively more negative as compared to left hand side. So how would we say that it has become relatively more negative? We would say that it has a partial negative charge. You guys know what partial charges are because we have already discussed dipoles, and we see that if there is an electronegativity difference, the shared pair of electron when stays more towards the atom, and any one of the atom, it has a partial negative charge. But this partial negative charge is not due to the shared pair of electrons. This partial negative charge is due to the more number of electrons passing from the right hand side of the atom. And this happens only for a brief instant of time. After this instant, what will happen? These electrons will move from one, like these electrons would then disperse Maybe some of the electron come toward left hand side and some of the electron stays toward right hand side. Maybe at some other point in this around this atom, then they gather together. मतलब आगे for let's say after another brief instead of time, they may be passing towards the from the left hand side. और फिर क्या पता फिर आगे पीछे हो जाए. So this partial negative would come for a very brief instant of time. And if the right hand side is becoming a partial negative charge, it means the left hand side of this chlorine atom would be getting a partial positive charge. So each single atom may have a partial negative and the positive charge for just a while, and they may disappear and then reappear at other positions. मतलब यहाँ से हटके, let's say if now more of the electrons are passing from the this side, bottom पे ज्यादा है और top पे कम है, so what will happen? This side will get a partial negative charge and the side opposite to it will get a partial positive charge. That's why these are known as instantaneous dipoles. Instantaneous means for a particular instant. They will appear and reappear. They will appear, disappear, appear, disappear. And randomly they can be formed anywhere around the atom. If we have two atoms in a molecule, we can say that this whole molecule may have a partial negative charge on one side and a partial positive charge on the other side. If you see a chlorine molecule, let's say this chlorine molecule will have a partial negative charge on this side, then it will have a partial positive charge on the opposite side. Now, if you just consider a chlorine molecule adjacent to it, what will happen? These partial negative charge, due to the more number of electrons passing from this side, will repel the electrons in the other adjacent chlorine molecule or the atoms of other chlorine molecule towards the opposite side. भाई जब ये यहाँ पे charges आएंगे, जैसे if you recall from your O-level physics, if you bring a positively charged rod or let's just say a negatively charged rod towards a metallic sphere which was originally neutral, it means it had positive and negative charges spread out equally in everywhere in this metallic sphere. But when you bring a negatively charged rod towards this metallic sphere, what used to happen? That the negative charges were repelled by these negatively charged electrode or rod, and the negative charge would move towards the other side of the sphere. The same thing will happen with the atom. The negative partial negative charge on this chlorine molecule would repel the electrons in the adjacent chlorine molecule, and they will move towards the far side or the right hand side of the other chlorine molecule. So the far side of the other chlorine molecule would get partial negative charge, and the side closer to the partial negative would get a partial positive charge. And these partial negative and positive charges would then attract each other. Obviously, as these charges are formed for a brief instant of time, this force of attraction will be there for a brief instant of time, and then it will disappear. Then it may recreate it at the other side of the chlorine molecule. Maybe the other chlorine molecule will get a partial negative charge. It will induce the partial positive charge on the other chlorine molecule. You know what induction is? Induction is basically charging the other object without touching it. Same thing is happening over here. The process that you used to study in physics is used to known as charge induction. Induction is inducing the charges without touching it. So this force of attraction is known as IDID. Instantaneous dipole, because on the first molecule dipoles were created instantaneously for a very brief instant of time. And these instantaneous dipoles have induced the dipole into their adjacent molecules. That's why this type of force is known as instantaneous dipole induced dipole forces. Previously, they used to call it temporary dipole induced dipole forces because these dipoles were used to be created temporarily on one molecule, and then they could create or induce dipoles on the adjacent molecule. तो पहले इनका नाम temporary dipole induced dipole भी होता था. अब updated syllabus में they call it instantaneous dipole induced dipole forces. Yes, every element can have induced dipoles, but these dipoles are so weak and so small and for a very brief instant of time that if let's say if you say Would they be there in the ionic compound? Yes, of course. They would be there. But they are so less significant in an ionic compound that we do not have to consider it in front of ionic bond. Would they be present in the metallic bond? Yes, of course, they would be there in the metallic bond because metallic bonds are made up of metal positive ions and metal positive ion have electrons revolving around them, of course. ठीक है, वैलेंस शेल के इलेक्ट्रॉन निकले हैं ना, बाकी सेकंड और फर्स्ट शेल और जितने भी इनर शेल्स हैं उनके इलेक्ट्रॉन्स तो रिवॉल्व कर रहे हैं ना, तो वो क्या इंस्टेंटेनियस डायपोल क्रिएट कर सकते हैं, बट दैट वुड बी सो लेस सिग्निफिकेंट or insignificant that we do not have to discuss about it in case of ionic bond and metallic bond. But as for the simple molecular structure, there is no other type of force between the molecules. The only type of force that is created is due to these instantaneous dipole and induced dipole forces, and it is so weak. That's why simple covalent molecule have low melting and boiling point, because if it just gain a little amount of heat, these forces would break and these chlorine molecules would move apart from each other. It means that its state has been converted. That's why they have low melting and boiling point. Okay? And these charges are, if we just make a charge like this, it means partial charge. And partial charges are also known as incomplete charges. Similarly, this is a partial negative charge and this is a partial positive charge, right? So ID would be present in all the simple covalent molecule. Like 2 chlorine molecule would have ID. 2 HCl molecules would have ID. Every simple covalent molecule would have ID forces between them. Right? What will happen to the electrons if the bond is heated? It depends how much heating you are providing. If you are providing a amount of heat that is unbearable for the electrons, they would move away and the bond would break. अगर सोडियम क्लोराइड हो तो सोडियम क्लोराइड में भी ID होगा, but thing is that sodium chloride has a much stronger bond which is ionic bond, so we do not have to talk about ID. They are insignificant in front of sodium ion and chloride. Now the other type of intermolecular force is permanent dipole forces. Now you can just realize with the name permanent dipole, in the first type you have instantaneous dipole, means dipoles were being created and then they were being disappeared. However, in permanent dipole, it means dipole must be present permanently, and you know already how dipole stays permanently. Permanent dipole forces can also be called as PD in short. And how it is formed? Whenever we have two bonded atoms, of course covalently bonded atoms. When we have two covalently bonded atoms having a greater electronegativity difference between them, then what happens? Let's say if we consider a molecule of HCl, chlorine is more electronegative than hydrogen, so the shared pair of electron always stays more towards chlorine atom. So chlorine has a permanent partial negative charge and hydrogen has a permanent partial positive charge, right? So if we just see two HCl molecules adjacent to each other, they have permanent dipoles. And these two permanent dipoles, a partial negative and partial positive, would definitely attract each other. And this type of intermolecular force is known as permanent dipole forces. Would they have ID forces? Yes, of course they would have. Because these have atoms which have electrons revolving around the nucleus, so they would also have partial negative and partial positive charges. Instantaneous dipole induced dipole forces होंगी इसमें. But these ID forces are actually insignificant in front of PD forces. तो हम PD की बात करेंगे, ID की बात नहीं करेंगे इसमें. Although they would have ID forces, but every simple covalent molecule would have ID forces between them. But in case of HCl, due to the electronegativity difference between the bonded atoms, a chlorine atom and a hydrogen atom have a permanent dipole as well. So which are more stronger than the instantaneous dipole induced dipoles. So right now the main type of force in a HCl molecule is PD force. The stronger type is PD force. So we will talk about PD forces in case of HCl molecules. अहमद, हम आयनिक की बात बेटा इंटरमोलिकुलर फोर्सेस में वी वोंट डिस्कस आयनिक कंपाउंड. लेट्स कंसीडर दैट आयनिक कंपाउंड्स हैव आयनिक बॉन्ड्स बिटवीन देम, नो इंटरमोलिकुलर फोर्सेस. HCl आयनिक क्यों नहीं होता? बिकॉज द इलेक्ट्रोनेगेटिविटी डिफरेंस बिटवीन द क्लोरीन एंड हाइड्रोजन एटम इज नॉट दैट मच दैट अ क्लोरीन एटम कैन स्नैच द इलेक्ट्रॉन फ्रॉम द हाइड्रोजन. Hydrogen would still cling to its electron. It won't just leave its electron. So the bond is due to the sharing of electrons. Samair, every simple covalent molecule would have ID forces. Why? Because it is due to the revolution of electrons around the nucleus of any atom. HCl molecule also have a electrons revolving around it in both of these atoms, chlorine and hydrogen. तो आईडी फोर्सेस तो सब में होंगी, बट यहाँ पे आईडी फोर्सेस की बात करना बेकार है, क्योंकि उससे बहुत स्ट्रॉन्गर टाइप की इंटरमोलिकुलर फोर्स है पीडी. मतलब आईडी फोर्सेस आर इनसिग्निफिकेंट, मतलब उनकी कोई वैल्यू नहीं है अभी बात करने की इसके सामने. गेटिंग माय पॉइंट? Wajiha is asking, if there are no intermolecular forces in ionic compound, then why do they have melting and boiling points? Wajiha, they do not have intermolecular forces, but they have ionic bonds, much stronger than the intermolecular forces. So whenever we have to change the state of any ionic compound, we have to separate these cations and anions. So in order to separate them, we have to overcome the forces of attraction. These forces, ionic bond is due to complete charges. Intermolecular forces is due to partial, incomplete charges. So ionic bond is much stronger. मतलब इनको कंपेयर करना भी तौहीन है आयनिक बॉन्ड की. गेटिंग माय पॉइंट? आप लोगों का मिसकंसेप्शन ये होता है कि इंटरमोलिकुलर फोर्सेस आर ओनली रिस्पॉन्सिबल फॉर मेल्टिंग एंड बॉइलिंग. नो, आयनिक कंपाउंड में आयनिक बॉन्ड्स आर रिस्पॉन्सिबल टू चेंज द स्टेट. You have to break the ionic bonds. In metals, you have to break the metallic bonds. In simple covalent molecule, you do not have to break the covalent bond. You have to break these intermolecular forces. पीडी में डिफरेंस ये हुआ कि जो पीडी बन रहा है वो परमानेंट डायपोल्स की वजह से बन रहा है. देखो बेटा, क्लोरीन मॉलिक्यूल में दोनों क्लोरीन एटम्स थे, इन पे परमानेंट डायपोल्स नहीं आते क्योंकि इनका शेड पेयर ऑफ इलेक्ट्रॉन स्टेज एग्जैक्टली एट द सेंटर. दे डू नॉट हैव परमानेंट डायपोल. They only have instantaneous dipole that can be created anywhere around the molecule, and they will be created and then they will disappear. Again, they may appear at other point and they may they may appear at one point and then they will disappear from this point. But in case of permanent dipole, they will always stay in their position. There is a difference. And if the dipole are staying in their position, it means they must be stronger as compared to instantaneous dipole, because instantaneous dipole तो on and off आ रहा है जा रहा है, और वो जो आ रहा है वो बहुत छोटा आ रहा है. लेकिन परमानेंट डायपोल में पूरा का पूरा इलेक्ट्रॉन जो है वो क्लोरीन की तरफ ज्यादा है दोनों शेड पेयर के, इसलिए उस पे जो डायपोल का वैल्यू है वो बड़ा है. गॉट इट? आगे बढ़े. अच्छा, कमिंग बैक टुवर्ड्स आईडी. आईडी फोर्सेस, अब जरा कुछ कंपेयर कर रहे हैं हम लोग ना. See, we have chlorine molecule and then we have bromine molecule. Bromine molecule also have no electronegativity difference between them. So they would have ID forces between them. And let's compare two iodine molecules. Iodine molecules again have ID forces between them because there are no permanent dipoles. But ID forces in iodine are strongest amongst these three. And ID forces in between two chlorine molecule is weakest. And the reason is because the number of electrons in a chlorine molecule are fewer as compared to the number of electrons in iodine molecule. So if there are more number of electrons in any molecule, the ID forces would be stronger. We will just compare it in a while. Okay? Let me just explain you the third type of intermolecular. I think it would be better if we just compare the factors affecting ID forces, then we can move on to the hydrogen bonding. Basically, if we see different covalent molecule with ID forces, so there are two factors affecting instantaneous dipole induced dipole forces. The first factor is number of electrons. If any molecule has greater number of electrons, it means the ID forces between the molecule would be stronger. More number of electrons in a molecule, stronger the ID forces. ID is instantaneous dipole induced dipole forces. Actually, ID forces is there in between all the molecules. But usually, when we compare two bonded atoms with zero electronegativity difference between them, तो हम उनमें होती सिर्फ ID है ना, सिर्फ ID की बात कर रहे हैं. मतलब अगर मैं HCl लिख रहा हूं तो उसमें परमानेंट डायपोल्स भी है ना. लेकिन अगर मैं क्लोरीन लिख रहा हूं तो मुझे पता है परमानेंट डायपोल्स नहीं है इसमें, तो सिर्फ ID होगी. ठीक है, तो हैलोजेंस में डायटोमिक होते हैं, सेम एटम्स होते हैं. लाइक इफ आई से आई हैव ऑक्सीजन मॉलिक्यूल and if I have chlorine molecule and hydrogen molecules, so ID forces would be all these three molecules have ID forces between them. Why? Because there are no permanent dipole in these molecules. Same type of atoms are joined together, right? So no electronegativity means no electronegativity difference means no permanent dipoles. Yes, ID and PD can exist at the same time. ID always exists. PD may or may not exist. For example, in these molecules, there is no PD. So which of these molecules have the strongest ID forces? Then you have to see the number of electrons in a molecule. Oxygen atom has 8 electrons. So oxygen molecule has 16 electrons. A chlorine atom has 17 electrons. A chlorine molecule would have 34 electrons. A hydrogen atom has 1 electron. A hydrogen molecule would have 2 electrons. So the greatest number of electrons are in a chlorine molecule. So the strongest ID forces would be in between chlorine molecule. Means chlorine gas must have a higher boiling point as compared to oxygen, and the hydrogen must have a lowest boiling point. Got it? Yes, Samahir, that would it do. यस अहमद, क्लोरीन के पास होंगी, तो क्लोरीन का बॉइलिंग पॉइंट हाईएस्ट होगा। गेटिंग माय पॉइंट? Now, if I just consider, let's say, the other factor that can affect IDID is surface area of molecules. Surface area of molecules can also affect IDID forces. Actually, I prefer them calling, syllabus calls them surface area of molecules, but it is more clear if we just use the word point of contact between the molecules. Because IDID forces are due to instantaneous dipole and the other dipole has to be induced. So for induction, two molecules must be closer to each other. Yes, Arish, between IDID, it will all between halogens, it would be, always be IDID, because if you see halogens, fluorine, chlorine, bromine, and iodine, same atoms are bonded to each other. So no electronegativity difference. So there won't be any PDPD, permanent dipole forces. Smaller molecule would have a no, IDID forces depends over number of electrons. No, surface area भी मैं समझा रहा, मैं बताता हूँ क्या मतलब है इसका। देखो, for example, if we have let's say butane molecule. Now butane does not have permanent dipoles, because if you recall from dipole moments, we have already established that the electronegativity difference between carbon and hydrogen is so small that you can just ignore that electronegativity difference between carbon and hydrogen. So we will consider that carbon hydrogen does not have permanent dipoles. Or even if they have permanent dipoles, that would be so small that we would just be considering ID forces in this molecule. So if we have two straight chain butane molecules, don't you think the instantaneous dipole and the induced dipole that can be created in between these two molecules would be greater in number, because the number of point of contacts between the molecule are greater. But let's say if we consider another isomer of butane, which is a branched isomer, we have the same formula. If the formula is same, it means number of electrons are same. Like number of electrons between two these molecules are same. So the first factor won't affect the boiling point. However, but let's say if we have this molecule with a branched carbon, so the other molecule, of course, would have fewer point of contacts between the molecules, because they have now the greater distance between them. Even if there is a ID instantaneous dipole, it cannot induce the dipole in the adjacent molecule, because it is actually very far apart from each other. So there won't be any ID forces in this region which are away from each other. But the molecule that are touching each other, the part of the molecule which are in very close to each other, they will have only ID forces. So if the point of contacts are come, that's what we say the surface area. Surface area means जो point of contacts है ना वो कम है, तो यहाँ पे ID forces weaker होंगी, क्योंकि fewer है ना, weaker ID as fewer point of contacts between the molecules. And this straight chain isomer of butane has higher boiling point due to greater surface area and more point of contacts between the molecules, so more number of ID forces, hence stronger ID and higher boiling point. मॉलिक्यूल क्लाउड, हाँ कह भी सकते हैं, नहीं भी कह सकते, थोड़ा सा सोच समझ के यूज करना पड़ेगा बट आगे बढ़े। मतलब आईडी forces you can also compare in between the molecule which are permanent dipole. Like अगर if I just asked you which of these molecules have stronger ID forces, instantaneous dipole induced dipole forces. I'm giving you two molecule HCl and HBr. So HCl molecules, two HCl molecules or two HBr molecules. Which one of these would have stronger ID forces? Now you just cannot say that K HBr molecule they would have permanent dipole or HCl molecule they would have permanent dipole, right? अब ये नहीं कहोगे कि परमानेंट परमानेंट पीडी ये तो हम आईडी की क्यों बात कर रहे हैं, आईडी भी होगी। अब क्वेश्चन इज आस्किंग यू टू कंपेयर दी आईडी फोर्सेस, तो करना पड़ेगा ना। तो we have ID forces between two HCl molecule and we have ID forces between two hydrogen bromide molecule। तो अब ID कम है, पीडी अलग कंपेयर करेंगे इनकी, अभी इनकी ID कंपेयर कर रहे हैं। तो किसकी स्ट्रॉन्गर आईडी फोर्सेस होगी, यू हैव टू सी द नंबर ऑफ इलेक्ट्रॉन्स इन ईच मॉलिक्यूल। इन HCl molecule hydrogen atom has 1 electron and a chlorine atom has 17 electrons, so there are total of 18 electrons in one HCl molecule. But if you see the number of electron in hydrogen bromide, hydrogen atom has 1 electron and bromine atom has 35 electrons, so there are total of 36 electrons in a hydrogen bromide molecule. So as more number of electrons are there in hydrogen bromide molecules, so they have stronger ID forces, right? So how boiling point actually depends upon the ID forces. If the ID forces are stronger, it means hydrogen bromide must have a higher boiling point as compared to hydrogen chloride, right? Okay, आगे बढ़े। अच्छा जी, the third type of intermolecular force that we need to discuss is, I think it would be better if we give this explanation. Oh boy. It is not actually a third type, but it is a subtype of permanent dipole forces. But just for the sake of note making, let's call it a third type. This is known as hydrogen bonding. Now, what is a hydrogen bonding? Whenever a hydrogen atom, when a hydrogen atom is covalently bonded with nitrogen atom, oxygen atom, or fluorine atom. Then molecules can have molecules have hydrogen bonds between them. And why I have just written inequalities with nitrogen, oxygen, and fluorine? Because fluorine is actually the most electronegative than these three, among these three, and nitrogen is the least electronegative, right? Now, if and consider any molecule with, for example, let's take an example of hydrogen fluoride. Is hydrogen fluoride bond in hydrogen fluoride, is hydrogen bonded directly with a fluorine atom? If you see the formula, it's a HF. Yes, hydrogen atom is directly bonded with fluorine. So if we see two hydrogen fluoride molecules adjacent to each other, now tell me, Hassan, you are asking something?
सर, ये हाइड्रोजन बॉन्ड का सवाल था कि हाउ विल वी नो व्हाट इज द स्ट्रेंथ ऑफ द हाइड्रोजन बॉन्ड अगर इन तीनों के अलावा हो कि नाइट्रोजन ऑक्सीजन और फ्लोरीन के अलावा किसी और चीज से बना हो हाइड्रोजन बॉन्ड दूसरा
Actually, if we do not consider hydrogen bond with any element other than these three, then we say that there is no hydrogen bonding.
अच्छा ठीक
Okay. However, we have to compare the strength of hydrogen bond among these three elements. इनका करेंगे अभी. अच्छा देखो, two hydrogen fluoride molecule, would they have ID forces between them? Of course, yes. Why? Because every two molecules, simple covalent molecule, they have ID forces. So do they have ID forces? Check. Yes. Okay, now, is there any electronegativity difference between these two atoms, bonded atoms, hydrogen and fluorine? Yes, of course. Fluorine has a, what we say, fluorine is in fact the most electronegative element of the periodic table, because when we discuss the electronegativity trends across the period, electronegativity increases and down the group it decreases, right? So chlorine is the rightmost and the topmost element of the periodic table, because after fluorine we have neon, but about neon we do not have to consider the electronegativity of neon. Why? Because neon does not make a bond. It is a noble gas. तो जो बॉन्ड बना रहा है उसी की इलेक्ट्रोनेगेटिविटी की बात होगी ना. अच्छा, so fluorine has a permanent partial negative charge, right? Because it has, it is more electronegative than hydrogen. So would this hydrogen fluoride molecule have PD-PD forces between them due to permanent dipole? Yes, of course. ये भी PD-PD भी होगी इसमें. तो PD-PD की ही वजह से there is one more force of attraction between these two hydrogen fluoride molecules, and that force is, देखो, fluorine molecule, oh sorry, hydrogen fluoride molecule में fluorine atom has lone pair of electrons. So what happens, due to these PD-PD forces, these hydrogen fluoride molecules get closer to each other due to these partial positive and negative charges. But ID forces are present in all the molecules, in all covalent molecules. अच्छा, अब ड्यू टू डायपोल ये मॉलिक्यूल करीब तो जाएंगे, ये जो लोन पेयर है ना फ्लोरीन पे, दिस इज ऑल्सो नेगेटिवली चार्ज. These lone pairs are also negatively charged. So one of the lone pairs, actually what does it do is it starts attracting this partial positive hydrogen of the other molecule. And don't you think, see, if you were considering IDID was in between partial positive and negative charges, and those charges that were appearing and reappearing again and again. Permanent dipole forces is also in between partial positive and partial negative charge, right? But this force of attraction is in between a lone pair. A lone pair has two electrons which have a complete -1 and -1 charge, and in between a partial positive charge. So don't you think this force of attraction would be strongest among these three, ID, PD? And this force of attraction is given the name hydrogen bond. And this force of attraction is known as hydrogen bonding. And in fact, when we show ID, we have just been showing it with a dotted line. PD, we also were just showing with a dotted line. But in case of hydrogen bonding, it is recommended that you show it with these straight lines, because they deserve some respect. They deserve some distinction from the other two types of intermolecular forces, because they are the strongest type of intermolecular force, and is it between a lone pair and a partial positive of hydrogen. So you have to show these forces in from the lone pair to the partial positive. You cannot just draw these forces from partial negative to partial positive. The most common mistake that you're gonna do would be you would just show these forces between partial negative and partial positive, and then you would label it hydrogen bond. That would be wrong, right? Let's see another example in which a hydrogen atom is bonded with, let's say, a nitrogen atom in this case. Ammonia molecule. In ammonia, hydrogen is directly bonded with nitrogen, right? If you see ammonia molecule, we have three hydrogen atoms bonded with a nitrogen atom. And nitrogen atom has a lone pair of electrons. And if we just consider two ammonia molecules adjacent to each other, so would these two ammonia molecules have ID forces between them? Of course, ID forces तो सारे covalent molecules के बीच में होगी ना. ID always exists. उमर, you asking something, और ये पहले का हाथ रेज हुआ हुआ है. तो क्या इनमें ID फोर्सेस हैं? यस ऑफ कोर्स, सब में होती हैं ID. क्या इनमें PD हैं? क्या क्या नाइट्रोजन इज मोर इलेक्ट्रोनेगेटिव देन हाइड्रोजन? यस. So hydrogen atom would have a partial positive charge in all the ammonia molecules, and nitrogen atom would have a partial negative charge. So would there be PD forces between these partial negative and positive charges in the adjacent molecule? Of course, PD भी exist करेगा. But as hydrogen is directly bonded with nitrogen, so the lone pair on the nitrogen would attract the partial positive of the adjacent ammonia molecule. So there is a hydrogen bond between them as well, right? That's why if you just like compare the boiling point of HCl molecule and hydrogen fluoride molecule. Hydrogen fluoride has a very high boiling point in front of HCl. Despite the ID forces between hydrogen fluoride molecule are weaker and HCl molecule are stronger. You know what? Let me just show you one thing. Yes, Umar.
इलेक्ट्रॉन जो इलेक्ट्रोनेगेटिविटी होती है, तो उसमें से हम कितने याद करें? आई थिंक 10% है जिनकी हमें दी हुई है. तो अगर हम नाइट्रोजन, ऑक्सीजन एंड क्लोरीन और हाइड्रोजन का कर लें याद, तो वो सफिशिएंट होगा.
आप कोई भी
या
याद,
बाकी सारे भी करनी?
नहीं कोई भी याद करने की जरूरत नहीं है, क्योंकि
ऑलराइट।
just have to remember the trend, because nitrogen, oxygen and fluorine, they are in the same period, right? And across the period electronegativity values increases. So
एंड
just
डाउन द ग्रुप ओके।
relatively know about this. You should be able to compare it relatively, that fluorine atom is most electronegative in between these three. Oxygen is lesser electronegative, and the least electronegative among these three would be nitrogen, because it comes on the left hand side of the periodic table. Okay, if you just let us just make a third example of hydrogen bonding, water. Because in water we have hydrogen atom. We have already taken the example in which hydrogen atom is bonded with fluorine, with nitrogen in ammonia, and with oxygen in water. So if you see two water molecule has an oxygen atom with two lone pairs. An oxygen atom has a partial negative charge, and these two hydrogen atom has a partial positive charge. If you see another water molecule, because water molecule has a band shape, इसलिए मैं shape बना रहा हूँ for a reason. Now if you see, let's just make one more water molecule. So the oxygen's lone pair would attract the partial positive of hydrogen, right? And here we have another water molecule that would also attract its partial positive hydrogen. Let's make another water molecule. If you see the water molecule in the middle, you see that oxygen can make two hydrogen bonds. Each water molecule can make two hydrogen bonds. ओके समाहिर, अभी क्वेश्चंस करेंगे ना, आ जाएगा समझ. So a water molecule would have, again, yes, does this mean water will have, two will have all these three forces? Yes, of course. So समरा, थोड़ी सी देर और लगेगी, अभी खत्म नहीं हुई क्लास. वाटर मॉलिक्यूल अगेन आईडी आईडी फोर्सेस भी होंगी, पीडी पीडी भी होंगी, बट एज हाइड्रोजन बॉन्ड्स आर द स्ट्रॉन्गेस्ट टाइप इन दिस, तो हम हाइड्रोजन बॉन्ड की बात करेंगे. So each water molecule can make two hydrogen bonds with the other water molecule. ठीक है. अच्छा, यही बात आप मुझसे हाइड्रोजन फ्लोराइड में भी पूछ सकते थे कि why हाइड्रोजन फ्लोराइड is not making two hydrogen bonds, because फ्लोरीन एटम has more three lone pair of electrons. जैसे ऑक्सीजन के पास two lone pair है, तो चलो बना लिया. लेकिन हाइड्रोजन फ्लोराइड में ऐसा क्यों नहीं हो रहा? वो इसलिए ऐसा नहीं हो रहा क्योंकि हाइड्रोजन फ्लोराइड में हाइड्रोजन एक है ना. अमोनिया में ऐसा क्यों नहीं हो रहा? क्योंकि अमोनिया में लोन पेयर एक है नाइट्रोजन के ऊपर. सही है. तो इसलिए अमोनिया मॉलिक्यूल और हाइड्रोजन फ्लोराइड मॉलिक्यूल में ईच वाटर अमोनिया मॉलिक्यूल वाज जस्ट मेकिंग ओनली वन हाइड्रोजन. But in case of water molecule, each water molecule can make two hydrogen bonds. Right? Each H2O molecule, अहमद बस थोड़ी सी देर और, can make two hydrogen bonds. So don't you think if hydrogen bonds are more in number, so the water molecule would have the highest boiling point of all these three? So hydrogen bonding would be strongest due to more number of hydrogen bonds. Strongest in water amongst H2O, NH3 and hydrogen fluoride due to more number of hydrogen bonds. यस, वाटर की फोर्सेस सबसे ज्यादा स्ट्रॉन्गेस्ट होंगी। अभी थोड़ी देर पहले कोई पूछ रहा था, लाइक अगर मैं आपसे स्ट्रेंथ ऑफ हाइड्रोजन बॉन्ड कंपेयर करवाऊं बिटवीन these three molecules, if I just ask you to compare the strength of hydrogen bonds between hydrogen fluoride molecules, ammonia molecules and water molecule, मतलब ammonia, water and हाइड्रोजन, अगर मैं आपसे इसकी दो अमोनिया मॉलिक्यूल के बीच में जो हाइड्रोजन बॉन्ड बन रहा है और जो वाटर मॉलिक्यूल के बीच में जो हाइड्रोजन बॉन्ड बन रहा है और टू हाइड्रोजन फ्लोराइड मॉलिक्यूल्स के बीच में जो हाइड्रोजन बॉन्ड बन रहा है, तो इनमें से सबसे ज्यादा स्ट्रॉन्गेस्ट हाइड्रोजन बॉन्ड किन के दो के बीच में होगा? देखो, स्ट्रॉन्गेस्ट हाइड्रोजन बॉन्ड होगा हाइड्रोजन फ्लोराइड का, वीकेस्ट हाइड्रोजन बॉन्ड होगा अमोनिया का। वाई स्ट्रॉन्गेस्ट हाइड्रोजन बॉन्ड हाइड्रोजन फ्लोराइड का? बिकॉज फ्लोरीन इज मोस्ट इलेक्ट्रोनेगेटिव, फ्लोरीन इज या इसको ऐसे लिखो बल्कि इलेक्ट्रोनेगेटिविटी of fluorine is greatest. Electronegativity of nitrogen is lowest. वाटर का कहीं बीच में आना चाहिए, राइट? अच्छा, लेकिन अगर हम इनके बॉइलिंग पॉइंट कंसिडर करें ना, बॉइलिंग पॉइंट्स, तो जिसका क्या कहते हैं आयनिक बॉन्ड, सॉरी, जिसका हाइड्रोजन बॉन्ड स्ट्रॉन्गेस्ट है उसका बॉइलिंग पॉइंट सबसे ज्यादा होना चाहिए, राइट? लेकिन अगर इनके आप बॉइलिंग पॉइंट देखो तो बॉइलिंग पॉइंट अमोनिया का जो होता है वो होता है अराउंड -33 डिग्री सेल्सियस, ठीक है? और बॉइलिंग पॉइंट अगर आप हाइड्रोजन फ्लोराइड का देखें तो हाइड्रोजन फ्लोराइड का बॉइलिंग पॉइंट कितना था? माइनस, इसमें नहीं था, ये प्लस में था, लेट मी चेक। हाइड्रोजन फ्लोराइड का बॉइलिंग पॉइंट इज अराउंड, लिखा हुआ था, हाँ, इट इज अराउंड 20 डिग्री सेल्सियस। एंड वाटर का बॉइलिंग पॉइंट तो सबको याद है, 100 डिग्री सेल्सियस। तो जब हाइड्रोजन बॉन्ड स्ट्रॉन्गेस्ट हाइड्रोजन फ्लोराइड का है तो बॉइलिंग पॉइंट वाटर का ज्यादा क्यों है? वाटर का इसलिए ज्यादा है क्योंकि नंबर ऑफ हाइड्रोजन बॉन्ड ज्यादा है, इट हैज मोर नंबर ऑफ हाइड्रोजन बॉन्ड्स, दैट्स व्हाई, not because the hydrogen bond between water molecule is stronger than the hydrogen bond between the hydrogen fluoride molecule, just because it has more number of hydrogen bonds, so more energy would be required to break more number of hydrogen bonds. Got it? So if they ask you in the question, why water has a higher boiling point than hydrogen fluoride, despite weaker hydrogen bond. That's because each water molecule make two hydrogen bonds. I think meeting got dropped for some reason. Can you guys see my screen? So each water molecule makes two hydrogen bonds. So more energy is required to break more number of hydrogen bonds. Okay, I think let us keep it till here. And then in coming class, we will have to we have to discuss something more about intermolecular forces पे कुछ questions करेंगे and एक homework दे रहा हूँ छोटा सा make hydrogen bonding between the following molecules. It would be better if you just say show hydrogen bonding between the following molecules. Number one is two ethanol molecules. Ethanol has a formula C2H5OH. H2O and methanol molecule. Methanol has a formula CH3OH. NH3 and water molecule. Okay, chal. Mahin was present. Yes, Samahir. We didn't record it. Yeah.